Okay, so this is our last talk of the night. This is Charles from the front side. He is a two-time speaker here at ReactJS Austin. If you haven't seen his first talk on Big Test, you should check it out. It's on our YouTube channel. It's a great talk. Goes through all sorts of unit testing, integration testing, and how they're not real, and some good non-traditional stuff. So check it out if you can. And he's going to continue his legacy with a talk on Redux Microstates.
All right. Hopefully I can live up to the hype. So actually that was a fantastic talk to go to follow because it segues pretty seamlessly into what I'm going to talk about. In fact, so much I'm actually going to include a shameless plug. I actually had a lot of trouble learning all this like formal functional programming, so I wrote a library that is dedicated to making all of these things really super accessible. We can go like, for example, I'll just show you in the README. I think functor is a fantastic name. There's my conceptual what I think a functor looks like. Like if you know, I just imagine like the funk parliament up there, and like, you know, the guy Bootsy Collins on the star guitar. He's like the functor of soul. But anyway, let me see. Back to let's see. We're back to playing the thing. So, oops. Where's my mouse? Is it up? Is it down? There it is. But it's a perfect segue because pretty much everything he talked about is actually in Microstates. Lenses, kerning, partial application, all of it. But you actually don't need to know any of it to use it. So with that said, my name is Charles. I'm Cowboy D on Twitter and GitHub, and pretty much anywhere else, any other social service you're going to look at. I'm the principal engineer at Frontside, and I'm here today to reveal to you one of the most transcendental truths of the universe, a reality that is so profound that you actually, I want everybody to like hold onto their scalp, keep it from like splattering on the ceiling when your mind blows. And it is this. You can increment numbers. I'll let that sink in a little bit. Numbers are things that you can increment.
I don't buy it.
Yeah, I know, it's crazy. It's crazy, but it's true. Numbers are things that we can increment. And so, you know, as programmers, we find ourselves incrementing things a lot in our code, right? So like, if you use Redux, this might actually look familiar. You might see code of yours that looks like that, right? That's because incrementing numbers is something that you can do with numbers. It's not just Redux, right? If you're using some other state management solution other than Redux, you know, you're going to see something similar. This is what it might look like in MobX. Or if you don't like MobX or Redux, you can use some artisanally handcrafted state management solution, but you're going to still have, you know, something that looks very similar. Or maybe you're just, you know, you're a minimalist, you don't like any of that, you're going to use state management, or you're going to use setState, which is just, you know, about as bare bones as it gets. But it all looks pretty much the same. We're adding one to a number. And these are great solutions for this problem. But I just have one question. Just one question. Like, why would we do that? Why are we, the programmer, telling the computer how to increment a number? Why are we saw it in Redux, we saw it in MobX. These are functional systems, and we're still saying, take the number that you have, value you have, add one to it, and return the next number, right? Numbers can increment. We know that, right? That's what they do. It's the same everywhere you look, no matter what kind of data you're dealing with, right? Arrays, well, you can push things onto arrays, right? If I have an array, I know that I can push something onto it. If I have a Boolean value, I know that I can toggle it. But just for like argument's sake, let's like unpack this a little bit. I know this is, you know, well, let's break it down. You know, what is a Boolean really at its core? Well, there are two values. you know, there they are right up there. There's true on one side, it's false on the other. That's it. There's no other values in Booleans. And furthermore, we know if we have one of these values, how to get to the other value. And if we have that value, how to get to the other one, right? We can toggle it, right? We can toggle it back and forth. And like we just know it, right? I mean, there's some other operations you can do. You can take a false value and set it to true, and a true value and set it to false. And you know, you can switch between those two things, but that's pretty much it. Boom. Boolean value, done, right? That's all it can do. And like, you know, that's just a fundamental property of it, because like 19 billion years ago or whatever, when the universe was kind of dust floating around, like Boolean values were there. Like way before we came along and discovered them. And like, I got some sad news, but like when the sun dies and like swallows all the inner planets and, you know, Earth is over and you and I cease to exist, Boolean values are still going to be there, right? They're just, that's what they are, right? It always has been, always will be. And the operations that are on those Boolean values, that's what makes it a Boolean value, right? So they do not change. So if we know that a number is a number, and we know that a Boolean is a Boolean, and we know that an array is an array, then why on earth are we reinventing them from scratch every single time, right? Because that's what we're doing, right? This is kind of boilerplate. We're telling how to increment a number, right? Whether we're using Redux or MobX or unstated or setState or whatever. And so you might be kind of thinking to yourself, maybe, you know, you're kind of agreeing with me, but you might be thinking like, you know, you might think I'm overdoing it a little bit here, right? It's like, come on, let's get a little perspective, right? And when we're dealing with one value, that makes sense, right? And if the story ended with just one Boolean or one number or one array, you know, that probably wouldn't be that big of a deal, right? But of course, that's just the beginning, because it's not that working on individual pieces of data is hard. It's just working with them in other values can get out of hand and can grow in complexity really fast, right? And that's hard to square with like, I've got this simple little value. It's so adorable up there. Look at it just kind of sitting there floating. It's wonderful, right? How is that complex? But the fact is that a Boolean value becomes the completed status of a to-do item. And then the to-do item gets composed into an array of to-do items that's contained inside your to-do list. And so we had this, you know, one little Boolean value. And so that's what you end up with, is to actually work with that. You've got to punch through 3 levels of complexity, right? And so here's what the reducer looks like to toggle this Boolean value. But you can see that by far and away, the majority of this code is dealing with unpackaging it from its structure, actually flipping the Boolean value right there, and then packaging it back up, right? Literally 70% of the code is dealing with the structure of the data and not the actual task at hand. And it's a lot of work actually to manage this value. And that's because what is simple in theory can become complex, and as you add context to it, that complexity is compounded at every level, right? And so this is a relatively simple example between a relatively simple reducer, but we've already seen how just those 2 layers of context can actually balloon the code and make you're dealing with the layers of context and not with the actual value that you want to deal with. And so we got to take a moment here and say, wait a second, this should not be complicated, right? Numbers are things you can increment, among other things. They do a lot of other stuff. Booleans are things that you can toggle. Arrays are things that you can push and pull off of. Like, it shouldn't be that complicated. I should be able to put these things together, right? It should be as simple as saying, you know, hey, what if I could just say, I've got some number and I want to increment it to get a bigger number. Or I've got some Boolean value and I want to toggle it to get the inverse of that Boolean value. Or, taking it up, I've got an array and I just want to push something onto it. That's all I want to do, right? What if I could just do that? And that's what Microstates is about. It's to make working with that data literally that easy so that you can focus on expressing the model and not worry about working with the structure of that model. Not having to worry about the glue that sticks the individual component parts together. I mean, we want to make state management easy. We want to make it fun. Like, we want to feel like you're coasting downhill, like you're winning, right? And I don't think that we get that from the current crop of state management solutions out there. So easy and fun, right? State management. Ooh, that's hard. That's a hard ask, right? That's a pretty bold claim. So there must be something that's different, right? About doing it with Redux or MobX or unstated, something that sets it apart. And what that thing is, it's actually something that you find a lot in functional programming, but it's something that we're all familiar with as programmers, is the concept of type, right? I've been kind of alluding to it. Numbers can increment, Booleans can toggle, arrays can push, right? That's the type of your data. The idea that there are intrinsic operations that cannot be separated from that data, right? That we know beforehand, right? We have knowledge. If we know its type, we know this type of something is a number, we know that it can increment. We know that that's what it can do, right? Everywhere. And so this code, while it's functional, is actually untyped, right? JavaScript itself is typed, is strongly typed, but this Redux code, even if it's written in TypeScript, is actually untyped. And so when you don't leverage that type information, you end up having to deal with a lot of boilerplate about what you can do with that data because you don't know it ahead of time. You don't know what the structure is. You don't know the operations that you can do on it. On the other hand, if you have something with strong types, then you can really mine the implicit data that's associated with, the implicit operations and structure that's there with the data that you're operating on. So quick divergence, because we talked about type. What about static type systems like TypeScript, right? This seems like it's a pretty well understood problem. There's a lot of things. There's Flow, there's TypeScript, or maybe there's PureScript and Elm and things like this. Is this a solved problem? I've probably the one I have the most experience with is TypeScript, and it's got an amazing type system. But the thing is the type system at TypeScript is available at compile time. It's a development tool. Right? It actually doesn't contribute anything to your runtime. It doesn't contribute anything. I think it does contribute to how you express your programs, but it doesn't give you any functions, right? It's not a library. It doesn't give you a function you can call when a user clicks on a button or something. It helps you generate correct JavaScript, but all of the type information that's there in your code is gone at runtime. So it helps your IDE, it helps your debug process, it can help you, your linters and whatever, but it doesn't actually help you express your runtime. So Microstates comes with a composable type system. And so it's a type system that's there for you at runtime, and it helps you express the logic of your application, and you express the models in your state just as a composition of various different types. So, of course, there are built-in types that it comes with, and all of the types that we're going to be seeing later are, taking these core types and, building them up into more complex data structures. Some of these types will be shocking to you. We've mentioned a couple of them before. The first of them is number. And so this is actually how you create a number in Microstates. It's very aligned with the way that you create objects in JavaScript. The only difference is with this create, instead of taking a prototype and a set of property descriptors, we take a type and a value. And that's really, at its core, if I had to describe Microstates as one thing, it's the union of a type and a value. And that value is just a simple serializable plain old JavaScript object. But then once you do that, then the fact that I can increment it is now implicit. And so in this code, we take that number, we increment it, and we get a new number, because it doesn't mutate the old number, that's one bigger than the other. But the point is notice the number 1 appears nowhere. I didn't tell it how to increment, right? I just know that I've got an increment operation. And of course, we've talked about this one. The same thing applies to the Boolean, right? I've got to create this object that represents a Boolean value, and I can get the inverse by toggling it. And I didn't have, point is I didn't have to write that toggle function, okay? If you create an array, you can see I'm going to create an array comprised out of this value, and now I can, push the green onto the colors, and I get a new microstate representing that array that's going to have all 4 of those things in its value, not and doesn't change the old value. Not unlike immutable JS, if y'all are familiar with that, except you're not constrained to 4 types. So again, these basic things that I showed you, number, Boolean, array, there's actually 5 built-in types. If you're working with them in isolation, it's actually not difficult. Because it's not about the difficulty of the operation, it's about the difficulty of composing those operations. And so what you want is a solution where as you compose your data into more and more complex data structures, it doesn't balloon out of control, which is I think what a lot of us see with our current state management solutions. We want to be able to add new values, new types, compose them together in novel ways, and have that complexity scale linearly. In other words, if we're programmers, we want to sit back, take a deep breath, lean on our type system, and let the computer do the hard work instead of having us do the hard work. So I've showed you kind of a little tour of the basic types. You can just create basic types. But eventually, we're going to want to create our own types, right? We're going to want to, take strings and take Booleans and take numbers and compose them into other types. So here's an example of this. It's a simple person model, okay? And it's expressed as just a simple JavaScript class that has 2 properties, each of which one is a microstate whose default number is 0. The other is a string that's the empty string, okay? And you can see this is kind of the abstract representation of that type. We've got the person that has 2 properties, name, which is a number, and string, which has, name, which is a string, and age, which is a number, and then there's a value. Again, we have at each node, we have the type and the value. And we're going to look at this one relationship right here, which is the age relationship. And what we can do here is what Microstates takes care of you. It allows you to compose these things for free, right? So I have a number, I'm able to put it on a person, and when I say person.age.increment, I don't get a new number, I get a new person whose age has been incremented by 1, right? That's what you would call, I guess, on someone's birthday or something. But again, doing that in a similar operation in Redux, you can compare these operations where what I want to do here is I want to toggle a Boolean inside of an array, inside a to-do, which is inside an array of to-dos inside the to-do list. Here, I've just got all of the information I need right here. This to-dos.to-do first element.completed. This path information tells me everything I need to know to unpack that data structure, make the toggle, and then pack it back up, right? So that's why with microstates, you don't have to do any of that yourself, right? So, we don't have this hodgepodge of spread operators. I think what I love about this is you get very clear intentionality about what it is that you're trying to do. I'm trying to toggle this completed value, right? you get that from that code. I don't know if you weren't familiar with Redux, if you would actually be able to define that. So we've talked about how we can compose types, but you can also add your own transitions, your own operations onto your own type. So when you do that, that transition becomes, that operation becomes as intrinsic to your type as it does to the Boolean value or the number. So here is a modal dialog. It's got two properties. It's got a Boolean, like is the modal open, is it closed? And it's got a title, right? What would show up on the bar? And then what we have is an operation called show that takes a string and it actually, sets its open to true and it sets its title to the string, and then it will return a new modal, right? Because it's immutable. It will return a new modal that has those properties set. So if I do this, now I've got that operation on the type, but it'll be composed. So in this example, these transitions are atomic. I've been essentially, we've been able to compose the data, but we can also compose the operations that are on it, right? So a show operation is composed of setting the Boolean value that is open and setting the title. So I'm actually seeing a lot of puzzled looks at this point. So I actually will stop right now and open up for questions. Like if anybody is like following, look at it.
So you're building this type as a class,
Mm-hmm.
and then in the next slide, you're just simply calling it with a create. Is that correct?
Mm-hmm. Yeah. So like in this, was it this slide? Yeah.
Yeah.
Right. So we defined it like this. So just like we could create a Boolean value or we could create an array, like we can define our own types, which are just simple JavaScript classes, and we call it with create. Right. So this is how we would actually instantiate that modal.
I have a dumb question. It seems to me that this code looks a lot like the object-oriented stuff of C++, C#, and Java.
It does.
Is this not going back to the future or something?
So actually, that's actually a question that's interesting. It's a question I get a lot, and I think that the answer is that mutable systems compose very well, right? If you work with just plain old JavaScript objects, it's very simple to say, I want to set this value on top of this, on this component, right? It's very easy to grasp. But when we want to, so we get the benefits of a simple conceptual model, right? And that's appealing. But there's drawbacks, right? We lose, the benefits of immutability. So it's hard to tell like how your data is transitioning. You have like shared mutable state, and so you can get inconsistent. It's difficult to get like a transaction log, things like that. To get those things, you have to go to like a functional style, right? But then you're stuck in this mode of unpacking and packing so you lose clarity as a trade-off for getting the benefits of function composition and everything. But actually, you can actually have the best of both worlds. And I think this is what this presents, because it isn't it might be a step back if it were introducing mutability, or it were introducing these aren't, you notice these transitions are all pure functions, right? We're always returning the next thing. We're not actually changing the current object. We're just describing from this current object, how do I get to the next one? So I think you actually get to realize the benefits of having both the simplicity of that object-oriented mutable design and also realize the benefits of immutability and pure functions.
Brief follow-up. I believe that you can write immutable code in C++, Java, and C# also, if you want to, right?
You can.
So it's not mutually exclusive.
Well, but if you do, then you also need to go through the same rigmarole that you do in normal FP. And so, like, spoiler alert, I actually don't have this in the present. It uses lenses under the covers, which is, how it's able to do this in a functional way. So, like, you can, and actually, prior to writing Microstates, we did JavaScript in a functional, in an immutable way, but again, we were still having to deal with unpacking the context changing the value, pack the context back
So
up.
you didn't say that this library is written by your company?
Mhm.
Okay, I didn't hear that.
Yep. Thank you.
So do you use this within the reducers to remove that stuff, or does this replace
This
Redux?
you could use it in reducers, but it pretty much replaces the reducers.
It works with Redux tools too.
Yeah, that's I should mention that. Yeah, so it's actually because the state is serializable, right? You just pass a value in with the type. You can always just take that out, and you basically there's an integration. We haven't made it public yet with Redux DevTool, so you can actually you can see your how your microstates change over time, and basically there's an action that contains the path of where you were making the change.
What if I wanted to show a modal but not necessarily change the title? Because here it looks like we're calling isOpen and toggling that, but then we're just setting the title. Like if you didn't want to change the title, we would still be setting the title. Like again.
You'd write it differently.
Oh.
Yeah, I mean, if you this is not a tutorial on the best model for a modal dialogue. It might be appropriate for one application. It's mainly just to demonstrate that you can batch up transitions from embedded data types and lift them into a higher level operation, right? So, maybe another example would be, I've got a transaction that has two accounts and it decrements, like by, realizing the transaction, I decrement one account and increment the other. Something like that.
Just curious, is this creating two, is there an intermediate stage after it sets isOpen? Or is this one operation that's setting both of those values?
It's one operation. In fact, what happens is this right here returns a modal, and then this returns a modal. Another modal, right? So you're just composing these two operations. So I just say, I take isOpen set true. That's got me one modal. I could stop there if I wanted to, but then, but at each point, every single line has a modal on it. The original modal, a modal with the isOpen set to true, and then a modal with the title set to the string.
Are there any React specific bindings for optimization, memorization type stuff that you would get from React Redux?
So I'll hold on to that one, and I'm definitely going to talk about that later on. Like I said, I saw some puzzled looks. Is there any other questions before we go on?
You showed a basic example how to increment integer or number, right?
Mm-hmm.
What if I want to increment by X amount, increment by 10? Do you create a new function to do that?
You could. So the actual increment method that comes with Microstates actually lets you pass a number. So you can increment by 10 or negative 10 or what have you. But you could also write your own. You could write your own type that allowed you to have whatever operations you wanted onto it.
Can you extend types?
You can't extend core types yet. We've talked about maybe a mechanism for that. So anyhow, so I just, there's a lot. Anytime you dive into a code section, it's that's where you get lost. I know I do.
You can extend custom types, right?
Yes, you can extend custom types. And yeah, there's only 5, and there's really only 5 core types: number, string, Boolean, object, and array. So what are the benefits of doing it this way? I mean, because that's what I showed you is really that's all there is to the API. Because this stuff isn't actually rocket science. We're incrementing numbers, we're concatenating strings. It's really all about how we organize it. And I think that there's a little bit more to the API that I'm not going to go into tonight. That you can kind of check out for yourself. But that's pretty much what I showed you is all that there is. But what comes packaged with this simplicity is there's really a lot of power in it, because you can assume so much. When your data is this normal and when you're packaging it this normally, you can make assumptions about these operations. So the first one is laziness, right? I think, did you talk about laziness at all? So what is cool about laziness is sometimes you can use this as a performance optimization. But with Microstates, you get it for free. And what that means is the transitions, when you make a transition, you're actually declaring your intent to transition a state, right? But actually the result of that transition isn't actually calculated until you actually need the content, right? So if I increment a number by 1 until I say, give me the value of the number, I don't actually add the numbers together. All the other solutions that we talked about before will do that eagerly, right? I'm not trying to pick on Redux. We use Redux in our application, or in one of our applications, and but it's eager, right? So is setState. It's gonna you dispatch the action. All the reducers are gonna run against that action. So example here, right? I've got this deeply nested data structure. I toggle the Boolean value until my render, React is rendering this to-do MVC, and it pulls the second to-do off the list, and it reads the completion state of the object. That's when the toggle actually happens. And so that's, it can be a subtle difference, but it's certainly helpful if you've got a lot of, if you're reading some WebSocket and you've got a lot, you're getting 100 events for every single render frame. Well, you're not going to do any computation until you actually do the render. Another thing is it's immutable, right? I'm not actually, in front of this audience, I'm not going to go into a deep dive on immutability since, React as an ecosystem is pretty centered around the fact that you've got immutable data. You're not changing it in between every set state. But, I think to your question, which is a very good one, is that we didn't have to trade. We didn't have to make any trade-offs in order to achieve that immutable API, right? We got to, it felt like we were actually mutating the data, even though we weren't. And so another thing is that we can, because it's immutable, we can derive state off of it, right? So I can actually just put getters right on that class, and it's easy. And because it's immutable, I can actually memoize that for free. And that's what Microstates does, right? Is because if it's a pure function, if the microstate is immutable data, then I've got this expensive operation here. Because the object hasn't changed and it can't change, that computation, that total computation is, if that's a pure function, so we're going to return the same thing every time. That means if I run it once, I can cache that result, and it's going to be the same if I run it once, if I run it 1 billion times, if I run it 1 trillion times, whatever. And that's nice because that's kind of the way that we're used to doing it in just plain old vanilla JavaScript. The other thing that's nice is it's serializable, right? We've got basically this type, and we're kind of putting this value into a box, but we're not changing it. We're transitioning it. It's going to change the value, but that value is just a regular JavaScript object. It can be serialized, it can be sent across the network. That's what we use to put into the Redux dev tools to show how it's changing over time. And so that also is a nice advantage. Another one is it's stable. Because we're able to reason about the data structure as a whole, and we're using lenses and things, if you've got a complicated data structure, if this part changes, nothing in the rest of the data structure needs to change, right? And that's important because, if you've ever tried to optimize a problem spot in React, you know that React is really super performant until it isn't, at all. And it can be a challenge, right? You can be challenged to avoid those pitfalls. And that has a lot to do with the instability of your values, right? The value, you're making some change, and you're cloning your object, and you've got something over here that changes, even though the data didn't change, and so you're dealing with keys and things like that. Microstates, you don't have to worry about that because it only updates the part of the data structure that actually changed. And so here's, we're going to do a quick comparison. And I don't know if everybody's ever used the React dev tools for highlighting what happens on a re-render. And so here, this is actually taken from the standard stable of to-do MVCs. We're going to see each one, and we're going to highlight when it updates. So you can see it's going to, anytime one of the React components updates, it's going to highlight it for the lens. And so here's the canonical setState solution. Is this going to play here? Yeah. So you can see it's updating the input field. So I'm updating the input field, but all these things are re-rendering right here, right? I do that, I check the box, I'm entering like every single time the whole thing like re-renders, right? Here's Redux. It's a little bit better, but it's pretty much the same thing. Like I'm dealing with this text field. Like Redux does a little bit better when you're entering in the text here. It doesn't re-render everything. But like when I'm doing the text field, everything else is re-rendering. MobX. It's pretty much the same. And so like a lot of times when we're writing our React applications, we don't even know that we're introducing these performance. We're doing these unnecessary and de-optimized re-renders, right? But like the problem is that optimization is like not something that we have time for or that we have the expertise, right? You got to get, call the optimization person. Like we've got features to ship, and we don't, we don't want to be in a position where we've written an app whose performance level is like the lowest common denominator of our team's understanding, right? Like if you want to invest the time in learning how to optimize React apps, that's like great, but like it's very easy. And so here, wait, let me, let's see. But anyway, my point is you want tools that will help you do the right thing by default. And so like, here's an example of that. If you look at the microstates, only the thing that is changing is the thing that's getting re-rendered. And that we actually didn't have to do any optimization on that app. And that's a simple app, it's a toy app, but like, it can get really hard to like optimize React applications. Another thing that you would expect, it's very, very simple. It's actually a small API. It's a very small library. It's about 5.5 KB gzipped, which, it's smaller than it's, I don't know if it's smaller than Redux. It's certainly smaller than Redux plus Reselect, which is what you would have to get by a wide margin to get some of these features. And so, that's pretty much it. Microstates is designed to be simple, it's lazy, it's immutable, performant, stable, and it makes it feel easy because you're getting all these things for free and realizing those benefits. For all of those things, there's this feeling that if I want to experience, go into the functional programming candy store and get all the goodies, I've got to experience all this pain, and I've got to it's going to be extremely disruptive to my code base. And I think that that's absolutely not true. And I think that Microstates is an example of that. So with that, I'll close it. I will say, at Frontside, we've definitely been thinking about UI problems and how to manage state for a really long time. And so we're building these solutions on, literally years of experience. So if you or anyone with your team wants help leveling up, we offer services in mentoring functional programming, software testing, we do project development. So, if that's something that's interested you, let's please get in touch. And with that's it. All right, were there, after the pause, any other questions?
So like, do you typically use this without Redux or just in conjunction with it, or how do you, what was like?
Usually typically use it without Redux.
So is it in the complete like fluxless type environment, there's no actions, nothing, you just have like, and normally you would just call setState, you just directly modify these classes or
so the thing is it's very simple, right? And so it can scale for a lot of different use cases. I would say the simplest use case and the best way to get started is just managing a component's state, right?
So I'm just trying to visualize it in relation to a component. And so would you keep the component's instance in state and then just
so there's actually there's a Microstates React integration. So this is framework agnostic, but there's a Microstates React so the default way is there's actually a component that uses, I believe it's the context provider API, and you just tell it what type of data you have and the initial value, and then it yields it into your component. It basically it uses a child function, so you pass it a render function as a child. I think it also supports a render prop. And then it provides basically the microstate and all the attached to the microstate are all the actions you can do it. So there's no like map dispatch to props, anything like that.
So you'd modify it directly, and then it would go through.
Yeah, and then it basically calculates the next step and then calls setState on itself.
Does it come with any like helpers or anything to say I want to share the state of this instance across multiple components?
You would just do that with the normal provider or props.
Yeah, so you're using React context and you put it at a high level to make it available.
So you kind of piggyback on.
That would be up to so yeah. So what the default React integration? It's kind of it uses we could actually pull it up here so I can.
We built a connect helper.
Yeah.
Does that come with it? Or?
No, like I don't like that API. So the provider component is a lot better because we have that stability for objects, right? So like we can change that one property and it's just going to change
anything that's a child of that provider component.
Yeah. So like for me, like I built a React Native app with it, and at the very top is my app model, and I have a bunch of microstates in it, and I change a value, it goes up to the top, and it comes down as props. So
is the provider different than context?
Context provider. Well, yeah, so there's the context provider and consumer, like is the React 16 API versus React 15.
Probably mixing names.
Yeah.
Changed it.
Right.
So
no,
there's
I'm just still learning that part, being a little hazy on that because I got seen the provider.
Right.
Like
outside of context.
That came in 16.3.
16.3.
Is that provider context or?
Yeah. I think so.
So I have like a two-part question, I guess. In the slide where you were showing the re-renders, was that in a React connected, so to speak, app with microstates, or was that a just JavaScript microstate app?
That was React.
Okay, so
yeah, because
right. So part two for me would be if React's like default way of choosing the re-render is like if something in the tree above it renders everything below, it's going to re-render, right? So I guess what is if it's probably the connected part of like the React microstates app, like what is that doing to kind of hook into that reconciliation process and prevent that from happening?
It's because it's triple equals everywhere. Basically, is the TLDR. So like you've got this tree of states, and if I want to change a state here, like it uses a lens set. To so basically that state and all the things above it change their object identity, but everything else remains constant. And so when React is actually doing the rendering, it looks and it says, oh, this thing is triple equals to the current prop. I don't need to re-render. And so the thing is you get to piggyback on like the most basic, most fundamental JavaScript operation to decide if something has changed. It's not like we don't have to do any hashing and say, are these objects equivalent? I don't have to walk any arrays or anything. It's like literally, it's triple equals. And so it's kind of, there's a referential transparency there, if you will.
For sure.
Is the intention to keep the number of functions for the native types small? Because I saw you just gave like the example for numbers increment, but like for string, I guess you could have a whole number of different functions. Is that just one example, or is there like a larger set of native functions with each type?
Yeah, so the answer is I was just giving those as examples of bundling the operation with the type. In general, we try and keep it in line with the actual kind of underlying mutable JavaScript API. So the microstate array is going to have all the methods that you'll see on a normal array. The microstate string will have the methods you would see on a normal string. So if it's there on JavaScript, and in fact, I actually found that for whatever reason, we hadn't implemented pop. We had push, but we didn't have pop. So there's actually an open issue to implement pop.
Okay.
Yeah, so you mentioned that this microstate supports Redux development tools, or you can hook it in.
You can hook it in, yeah.
So the transitions in the Redux development tools are in action with payload information on that. What constitutes the transition in microstates? Is it?
So it's just, so what's interesting, because it's so normalized, is you have basically the path of where you're actually doing the transition. You have the name of the method that you're dispatching. So, and then you have the actual microstate. So that becomes, you basically have, from Redux DevTools perspective, there is a single reducer and a single action, which is transition microstate.
Okay, so there's only one type of action that gets executed, but you represent each transition?
Yeah, so right, and so you'll see, like in the payload, you'll just have, it'll have the path.
Okay, so the label is the same, but the
it's actually
payload is the path.
Yeah, I wish I don't actually have a video of it, but it's actually just looking at it's actually way more helpful looking at a microstates in Redux DevTools than looking at Redux.
Charles, go to the Microstates channel.
Microstates channel?
I dug up the video.
Oh, you did? Okay.
It's better to watch.
Okay, yeah, we'll do that.
Yeah, I think I understand, but
well, it's yeah. We'll see. Oh, actually, am I connected to the internet? I am. Okay. It is Microstates. Okay.
Yeah, that one.
This one?
Yeah.
So look, how do we make this full screen?
It's on the bottom.
Lower right.
All right. Oh, there it is. Yeah.
Didn't pop up until you play.
Okay. So here's, oops.
Oops.
Ah. Okay, try that again. Okay. So you can see there's actually no Redux in this, just the Redux DevTools. But that's the nice thing about having, so it actually, it's like you could think of it as like a tool that generates a Redux store for you, generates all the action names, generates all the reducers, does all, like, that's one way a helpful way to think about it. But you don't have to actually write any of that stuff or wire it together, because it's just like, hey, I've got, I've got an app that has a name that has a string. And so to change that, I'm going to create an action name called app.name.set.
so if you click on state and action, what does that represent? I'm just curious.
The state is just going to be, actually can't, this is a video.
Oh, I'm sorry, that's right, this is a video. Sorry. There's no interactive videos though. All right.
The source code's out there, but I don't know where.
Yeah.
I was kind of curious what you represent.
Yeah. And so, but the state would just be that, when we pass the POJO into the microstate, it would just be that thing.
State,
Yeah.
and top level microstate.
That's right, so you're exposed to all the middleware too, so if you want to use that for metrics or something like that, you can watch your state change and do whatever you want with it.
Yeah, and you get time travel debugging out of the box for free. All that stuff.
Yeah. Yeah. We haven't released this package yet because it needs to be polished and what have you.
Do you model network requests as transitions on your?
You can, yeah. Yep.
When's Microstates router going to come out?
I'll leave that one to Rob. There's actually, one of the things that I really am interested in is having a history, a microstates history object that you can compose. So I can take any object and then just set it on a history and then have that basically keep the history of all the transitions. So you can get kind of undo and redo for free. Because, while Redux has the ability to keep a single atom, we don't actually see many undo redo solutions, because what you actually don't want to do is transition the whole atom or roll it back. You want to be rolling forward with a previous state.
So you mentioned that with this you get the kind of runtime type checking piece. For the static, do you just use prop types, flow, TypeScript?
You could write microstates in TypeScript, but it would check to make sure, like, if you called it with a number or something like that, and it returned that number, like, you wouldn't be able to then call a string concat on it. So you can definitely, everything that you can get from TypeScript, you would also get, like, you would actually do type checking on the return values of your microstates to make sure you couldn't use them in improper ways. Did that answer the question? Okay.
And so you used to do MVC a couple times the examples, and I'm wondering if in the documentation somewhere there's like we can see like a fully implemented like to do MVC using this.
I think there is.
The other thing, I had a second part also.
Okay.
And that was like, does any of this change when you like factor in like asynchronous stuff?
So, no, it doesn't, but right now we're still working on the async. Like it's very much in like the thunk days. Like it's bring your own side effects. Like this is just a model. It is pure. It can model side effects. So like to model network request, you would have a operation that's like basically saying it's pending. It's making progress. It's doing like this. But those are just you're just transitioning the model. You still need some other mechanism that controls this. It controls your microstate. What's that?
You have to roll your own XHR type or something like that, or upload type, or.
Yeah. I mean, what you would do is you would have like for example, we did one that was a file upload, and we had basically some side effectful code that was a bunch of promises, and the first thing we did was instantiate a microstate, and then just basically set state at each point. So inside the component, you would, when this promise resolves, you would call, the microstate had a reject and a resolve method and a progress method, but they just were capturing the state, if that makes sense. But right now, you have to make your own side effects and use the microstates model. So we'll see, that pattern is kind of still emerging, but what we really wanted to focus on is like, what does the most awesome model look like? And then we'll figure out how to work with it.
So you gave us examples of like a single, like most of your examples were just one level of nesting, right? I didn't see any kind of like basically setting nested data at all, like inside of the class. Right? So like do you do stuff like this, or would you basically say actually you should actually create a new model, right, for every sort of nested structure that you encounter? So this is an example. So in this, are you talking about like this? So here's an example of a nested data structure. And let's see. Or here's another example of a nested data structure, right? Like we've got a to-do MVC object that has a list of to-dos. Each one of those to-dos has a completed and a title. So we've got like 1, 2, 3, 4 levels of nesting right here. I would say so. I think that what I like about microstates is you can decide what level of nesting is appropriate, and you don't pay a penalty from saying, you know what, this property really doesn't belong here. I'm gonna pick it up and I'm gonna move it over there, and like you can just do it. And you don't have to like go and figure out, okay, now how the hell are my reducers matching on that data structure? Like you can, it's just by the fact that it's there, the code that now calls it, you have to change the code that calls it, but you don't have to change any of the code that implements it, implements like the actual change. So it reduces the complexity of moving data and refactoring your data. Did that answer your question? Yeah, because I have a small follow-up.
Okay.
So I was wondering, do you currently have like to-do.mvc.to-dos1.completed.toggle? Unfortunately, you didn't give any examples of how to define like a state like that.
So the thing is this is a Boolean value, Boolean microstate, and this is an array microstate. So I'll tell you what, let me.
Pull up the microstate model.
Yeah, I can just pull it up. So if we go to microstates and then we look at to do MVC, this will give you an example of what it looks like. Is it under examples? Yeah. So there's actually.
It's in the root.
It's in the root. Oh, that's right. Because that's the other thing is this model is actually shared between a React, a Skate, and a Vue application. So they all use the same microstate. They just use a different thing on top of it. So where is it an index?
There it is. Okay. So this is what to do MVC looks like in Microstates. This is actually using an older version, but you can see it's got an array.
Can you get an Apple Plus on that?
What's that?
Can you make it-
Oh yeah.
And maybe you showed this. I just want to see the
We
part where you define initial state as well.
So we didn't define. I mean, it was just a code snippet, so I didn't actually define the initial state. I can show you actually. I think we have. Well, tell you what. I think. Let's see. We'll do a little live demo here. We'll see if this actually works. Okay. And then I think, so if we look at, let me just, I've got a simplified version of to do MVC. So if we go ahead and look at this. So here's a simple thing that we use inside the test suite. So that's what it would look like. And then to initialize it, so you can see that the completed initializes to false. The title initializes to a string. So if I were to actually, if I said, I think, I have it, can I get at it? To do, let me see, is this a good idea? Yeah, okay. So, okay, so I can say create to do MVC. Right, and so you can see this is actually going to create a list of to-dos, and the state of the array is the empty array, and the state of this microstate is that thing. So if I wanted to create it with an initial state, I would say the to-dos is, you know, maybe title, get milk, spell that, and we'll just say, oops, I've got a syntax error. So help me.
The perils of coding inside.
Yeah, there, is that it? No. What am I doing wrong?
Like I would never.
Currently outside the race.
Oh, like this? Yeah, there we go. Boom. Okay. And so you can see now I've got this microstate that's got one to do already in it. And if I want to look at the state.
If you, I'm just curious, if you were to say add to-dos, which is an array, but then say tried to put a number in there, would you get like immediate feedback?
If I tried to put a number in there.
Get it run